For this lesson, our focus standard comes from Grade 8 Expressions and Equations, Standard 8. Analyze and solve pairs of simultaneous linear equations. Our topic for this lesson is our last one from Systems of Equations, More Practice Writing Systems of Equations. Our essential question is, what is the process for translating word problems into systems of equations? Please take a moment, pausing the video if you need to copy down the standard, the topic, and essential question in your header, along with today's date, set your question column and your note column, and resume the video when you're ready to begin.
So one thing I want to point out today for sure as we're working through is that this is going to focus only on writing the systems. We're not going to solve them. So know that as you're going through, that you're just expected to be able to write them for the purposes of this video. So I've identified 3 steps to do just that. The first step is to identify the 2 unknowns or the changing quantities and write your let statement for the 2 variables. Then, step 2, you want to identify how the 2 variables relate to one another and write it as an equation. And then you want to identify how much of one variable compares to the other variable and write it as an equation. So let's just jump right in and see how that looks when we do that. So here I have our first problem, which might seem a little bit familiar. We're looking at the sum of 2 consecutive odd integers is 76, and we're being asked to find the numbers. So right here, that alone should be your indicator of what we are looking for to find the numbers. Notice it's plural, so I'm guessing we need 2 numbers. It says 2 here also to validate that thought, so let's just keep it simple and use x and y, and we'll let x equal the first odd integer. I did say odd because we're talking about odd integers. And y is going to equal the second odd integer. So step 1 is complete. We know that we're looking for 2 numbers. They happen to be odd. So x is going to be the first one, y is going to be the second one. Now we need to identify how the 2 variables relate to one another and write it as an equation. Well, that is right here. The sum, I'm going to use yellow to highlight this, is 76. The sum is 76. Well, sum means to do what? Add them together. So we're going to get our first equation by taking x plus y, the first odd integer, plus the second one, add them together, and that will equal 76. So we've done the first one. The third one is a little bit hidden in this question. It says identify how much of one variable compares to the other variable and write it as an equation. Well, that is going to be right here, 2 consecutive odd integers. That is telling us how they relate. They're consecutive and they're odd. Integers, they just mean positive or negative whole numbers. So here I've actually shown a little bit here that I think is going to help us out. So I've listed out what the 2 odd, what a consecutive list of odd integers. I just happen to start at 1. They could be negative, but this is just going to help us to see how they relate. Consecutive means next to one another. So if I've listed out 1, 3, 5, 7, 9, 11, 13, so on and so forth, consecutive, if I'm looking at 2 of them, means it could be 1 and 3. It could be 3 and 5. Could be 5 and 7. 7 and 9, 9 and 11, or 11 and 13. So it has to be paired up. They have to be, when listed out as all the odd numbers, they'd have to be 2 odd numbers that are next to each other. So let's look carefully about how odd numbers compare. If it was 1 and 3, what would I have to do to 1 to get 3? Let's see if that holds. Can I do the same thing if it was 3 and 5? What would I have to do to 3 to get 5? And since it's a pattern, we want to make sure it would hold for any 2 odd numbers. If it was 5 and 7, what do I have to do to 5 to get 7? You might be noticing that you can just add 2 to the first and get the second. So this is how they relate to one, and this is how one relates to the other. The second one, if it was 1 and 3, the second one is always going to be the first one plus 2. Same if it was 3 and 5. The second one is always going to be the first one plus 2, so on and so forth. So that's how they relate to one another, and that's how much of one we need of the other. So how does one compare to the other? Well, the second, which is y, is always the first, which is x, plus 2 more. So I'm going to highlight this purple as well. And that helps us get our second equation. I can get the y equals the second integer by taking the first and adding 2. So we've written a system of equations. We have a let statement, and we have 2 equations that help us see the full understanding of the problem. So let's take another shot. Here's my second problem. We're talking about a couple of middle schools. Holmes Middle School has some students. George Middle School has 125 fewer students than Holmes. When the 2 schools are merged, there will be 809 students. How many students attend each school? Well, the question is always very helpful in helping us to identify what we're looking for. We're talking about each school, so I might even underline that. And we have a Holmes Middle School and we have a George Middle School, and there's some students at both of them. We're not sure how many, right? So we just need a variable for each of those 2 schools. So it'd be as simple as let h equal the number of students at Holmes and g equal the number of students at George. Holmes being Holmes Middle School, George being George Middle School. So step 1 is done. So how do they relate to one another? Well, this second sentence, or I guess third sentence, is very helpful. I'm going to highlight it yellow also. When the 2 schools are merged, there will be 809 students. What do they mean by merged? That's a key word here. I'm going to italicize it. Merged means that they're combining the 2 schools. They're putting them all together. Well, all together means what operation? Means adding, right? So if you take Holmes and you add George, you'll get 809. So there's our first equation. George plus Holmes equals 809. So now we need to see how much of one do we need to compare to the other. So we have George Middle School has 125 fewer students than Holmes. And I'm going to do this, I'm going to focus in on this word right here. Than. Than tells us to switch the order of things. Whatever came before it, so this George Middle School having 125 fewer students, that's going to, since it came first, it's actually going to go last. And since Holmes comes after the word than, it's going to go first. So than, when is comparing 2 things, that helps you look for that word and you'll find a way to write one of your equations, and then switch the order of it. So I know that the number of students at George Middle School is equal to 125 fewer students than Holmes. So what do I have to do to the Holmes? If it's 125 fewer students. Well, fewer, what operation makes things less? Subtracting definitely does. So it seems I could take George Middle School and set it equal to Holmes Middle School minus 125. George is 125 students less than Holmes. So Holmes minus 125 should tell me how many students are at George. And there's nothing to uncover here. Just thought I might need it to write some notes, but I don't. So there's our system. We have a let statement and a set of systems. Let's try a third one. Third problem says, Miss Kitts works at a music store. Last week she sold 6 more than 3 times the number of CDs that she sold this week. Ms. Kitts sold a total of 110 CDs over the 2 weeks. Now notice there's no question here, but a question is implied. Let's think about what the question might be. To me, it seems that it's asking us to find how many CDs she sold each week. Does that seem right to you? Talking about 2 different weeks, right? We know that from here. And we know different things about them, but we don't know the specifics. And so it seems like it's trying to ask us to find specifically how much did she sell. So that right here and underline that, that's helping us figure out what our variable should be. How many CDs she sold each week? Well, we have 2 weeks, right? We have the first week and the second week. So, simple as that. We can just use X and Y since W won't work because week 1 and week 2, right, both start with W. So we can just say X and Y. Let X equal the number of CDs sold in week 1 and Y equal the number of CDs sold in week 2. So X and Y, so step 1's done. Now let's see, how do they relate to one another? Is there any kind of combination or what? Well, it says Ms. Kidd sold a total of 110 CDs over the 2 weeks. That seems like an easy way to write an equation right here. It's talking about both weeks, so X and Y, and a total of 110 CDs. Well, what operation do we do to get total? If we have week 1 and week 2 and we know that together they're 110, if you said adding, I agree with you. So X is my first week and Y is my second. So I can just say, well, X plus Y equals 110. Because week 1 plus week 2 should combine together for a total of 110. That's what the sentence is telling us. So remember, I told you to look for that sneaky word than. This is going to help you find your second equation that you need. Oftentimes it does. I can't say it's always there. But than tells us how they compare to one another. And remember, it also switches the order. So it says, last week she sold 6 more than 3 times the number of CDs sold this week. So I'm going to highlight that. And so remember, than, I left those gaps here because it's telling us to switch. Whatever comes first goes last, and whatever was last comes first. So we need to figure out, last week she sold. So last week was the first week, right? So we know we're dealing with X equals 3 times the number. So I'm going right to the after part because I know that actually needs to come first. 3 times the number of CDs sold this week. Well, what variable represents this week? Week 2 or the second, right? Y. And 3 times that, well, it's telling us right here what operation to do. 3 times that. Well, that's 3Y. And then it says 6 more. Well, what makes things more? Addition, right? So the last week, which was week 1, so X, is going to equal 3 times the number of CDs sold this week. This week, the closest week is Y. So 3Y. And then 6 more than that. So 6 more, the only way we can make things bigger is to add 6 to it. So there's our second equation. Again, I just had this to jot some notes, didn't end up needing it. So we wrote we identified the 2 changing variables, and we wrote a system for it. Only have a few moments left, so I'm going to leave you with one problem that I want you to try on your own. Right here, the Frosty ice cream shop sells sundaes for $2 and a banana split for $3. On a hot summer day, the shop sold 8 more sundaes than banana splits and made $156. Just like in the last problem, you might need to come up with your own question that helps you identify your let statement, and then see if you can come up with your 2 equations, and we'll compare them in class. Alright, good luck to you. Can't wait to see how you did and compare all of our work.